and then we'll also give you some work time on some of those. But the question came up here just a minute ago. Jacob and I were just talking about one, so it made me think of this algebra situation. So I want to talk about this. If I've got this right up here, can I cancel these x's?
No.
You cannot cancel the x's. The only thing, and we get kind of carried away with talking about canceling. What you're doing is you cancel factors. What you can cancel are factors, because what happens when you cancel factors like 3 times 4 over 3, what you're doing is you're creating a 1. And since they're factors, they're being multiplied, and when you multiply by 1, the 1 doesn't really do anything. So you have to cancel factors. X is not a factor of the top up here. That's why I always talk about factoring out and then canceling, because it has to be a factor that you're canceling. All right, and so the same thing's true here. Can I cancel those e to the x's? No. I cannot, right? Now, if there was an e to the x over here, right, now I could factor out an e to the x and then cancel it. Or sometimes people just say, well, if every term up here has an e to the x, some people don't show the actual factoring. They just say, okay, I would pull out an e to the x, and then that would cancel with one of these, right? And that's what you're doing. So, and I wrote that because that looks like a quotient rule, right? I mean, that's what you get when you get quotient rule. You get some stuff that's multiplied together, because you do the derivative of the top times the derivative, or the bottom left alone. So you get some stuff minus some stuff all over one quantity that's squared at the bottom. So you need to be able to factor out of the quotient rule before you can then cancel. So you got to be careful of that. But we'll do some, probably get into some today where that can happen. All right. So which ones on the homework do we want to look at? By the way, I recorded block 2 and block 3. The only reason is there'll probably be different questions, and there might be different ones from page 195 that you want to see. So if you wanted to, for whatever reason, watch the other blocks or see which problems we did, scroll through there, see which problems we did, and whatever. I mean, that's just the only reason I'm doing it. Which one?
Number 6.
Number 6? What did number 6 say? Arctan of root 3. Now, I don't want to spend a lot of time on these problems because the most important thing is about the derivative stuff. But arctan of root 3, when you're doing that problem, that's the same as doing this problem. Okay, and this is one of the difficulties people are having with these arc or inverse trig functions. If I ask you what's the tangent, or when is tangent equal to root 3, people seem to be able to handle that a lot easier than arctan root 3, but they're the same question. They're the same question. Okay, here root 3 is the output for tangent, but here it's the input, because we said yesterday with inverse functions we're interchanging the inputs and outputs. Okay, well, when is tangent root 3? Well, you got to remember your unit circle. Okay, tangent is opposite over adjacent. Well, how do you get root 3? You take root 3 over 2 over 1/2. That's how you would get root 3. Okay, well, what angle is that? That's pi thirds, right? That's pi thirds. So arctan of this, that would be pi thirds. Now, what we also have to kind of remember, we talked about the thing with the calculator, right? The one difference in these two questions is, in this one, there could be many solutions, right? There's pi thirds, but tangent's also positive down in the third quadrant, so you could have, what, 4 pi thirds, and then you could have 2 pi multiples of that, or you could go negative and go the other way. There's infinite answers on this problem, but on this problem, there can only be one, because it's a function. So one input can only give one output, okay? And so this is where we talked about that restricted domain and those kind of things. If this would have been negative root 3, then we'd have been down here. Okay, and we would have used not 5 pi thirds, but we'd actually used negative pi thirds as the one. And so, and that, again, that gets that restricted domain stuff, which is something that it'd be good to know about and understand and be able to apply a little bit as we see it as we go through the year, but, not the hugest deal right now. Okay, what else? 23. What's 23 say? Arctangent, and then inside is square root of x. So it'd be like that, x to the 1/2. Okay, now, let me make another comment here about the derivative rules. Now, this came up in the other class, so I thought I'd share it with everybody. There was a little bit of confusion with some people about the u and the u prime and that kind of stuff, as if I've given you a whole bunch of new rules. It's not true. So we got these basic rules here. We did use u and v here in our product quotient rule. Remember what u and v are. They're just functions of x. They're just some functions of x. Okay? Now, we got our chain rule. And our chain rule is the most commonly used rule of all of these. It's when you have something on the inside, which we almost always have stuff on the inside of functions. Not always, but almost always. And so what we say is do the derivative of the outside, leave the inside alone, times by the derivative of the inside. Well, that's what the u prime is. The u prime is just the derivative of the inside. So this is just saying the rule for a power, if you have some stuff raised to a power, you do your regular power rule, you leave the stuff there, and you times by the derivative of the inside stuff. If you have e raised to some stuff, the stuff, the u, is the inside. So you do the derivative e to the stuff and times the derivative of the inside. So in all of these problems, these are not new rules. It's just reminding you that, hey, there's probably some stuff on the inside of that function. So when you do the rule, make sure you multiply by the derivative of the inside. But I think it can be helpful if you don't get confused by the notation. It can be helpful that make sure you do that you remember to multiply the derivative of the inside. Okay? You know, and so we got these other rules. So the rule we learned yesterday, what was this one again now? This was arctangent. Okay? So the rule for arctangent says if you have arctangent of some stuff, then the rule is 1 over 1 plus that stuff squared. So whatever's on the inside of arctangent is going to get squared right down there. That's the leave the inside alone part on the chain rule. So it looks kind of weird. It's, you know, usually we do sine, the derivative is cosine, and we leave the stuff inside the cosine just like it was inside the sine. That's different here, so it doesn't feel like you're leaving the inside alone. But that's what's happening when you're putting the stuff right there, squared, and then times the derivative of whatever's inside there. Okay, so when we go to this problem, first of all, it's what rule we have to do? Product rule, right? So the first thing we have to do is product rule. So we have to say, all right, derivative of the first, which is 2x, then we're going to leave the arctangent function alone, x to the 1/2. Then we're going to do plus, then we're going to leave the x squared alone, and now we're going to do the derivative of arctangent. Well, the derivative of arctangent, we just said, is 1 plus u squared on the bottom times then the derivative of the inside. That's the u right there, the x to the 1/2. So the derivative of arctangent is 1 over 1 plus the inside, which was that, squared. You can see why I wrote square root, because we're squaring it. Okay, we can do something with that. And then u prime, that's the derivative of the inside, is 1/2 x to the negative 1/2, like that. So that's what 23 would look like. Now, can we simplify it a little bit? Not much to do with that, but we certainly can do some stuff with this. Square root of x squared is just x. Okay, so the bottom here would have simply a 1 plus x, and there'd also be a 2 down there on the bottom because of the 1/2. Now, I could leave that 1/2 separate, that'd be fine. Okay, and now what about x squared times x to the negative 1/2? X to the 3/2, I think. Right? Because it'd be 2, take away 1/2, it'd be 1.5. So it'd be 3/2. So, and again, this is all one term here at the end because they're all multiplied together. So I can put it all together, the stuff on top, x to the 3/2, the 2, the 1 plus x. So that would all kind of simplify like that. This I can't really do anything with. So that's how I would, you know, that's one way 23 could look. Now, could I have left this last thing here? Could I have left a 1, oops. Could I have left a 1/2 here and then done an x to the 3/2 and then done 1 over 1 plus x? Yes, you could have done that. You could have just left it like that. That's fine. Okay? But you did need to put those x's together and add their powers, and then square root of x squared, that should be just an x. Okay? I would say so, yeah. I would say on this one, that would be one of the algebra things I'd want you to do. Simplify that, put x's together. Yeah. And that's one of the things we'll be working on as we go through the next few days. But also, keep in mind that there's a lot of problems that doesn't happen, right? A lot of the time, there isn't stuff to do, but you always want to stop and look at it and see if there are things that you can put together and simplify. All right, let's talk about 21. I don't know if anybody's going to ask about it, but some in the other class did, and there's usually plenty of people have questions about it. But arc secant of x over 2. We did not have a rule for arc secant. Why?
Switch the cosine.
We can switch it to arc cosine and do what? Reciprocal. In other words, let's look at it this way. If I tell you that cosine x is equal to 3/5, that tells you that secant x is equal to 5/3, right? One of the things you learn is, and this is how you probably always would say it, is that cosine and secant are reciprocals. But what does that mean? It means their output values are reciprocals. But think about what we did yesterday with inverse functions. Inverse functions, you do what with the x and y? Switch them, interchange them. Inverse functions, the inputs and the outputs are interchanged. They're switched. So, if secant and cosine have reciprocal outputs, that means arc secant and arc cosine have reciprocal inputs. They have reciprocal inputs. So, we can take this function, and that's the reason we don't have derivative rules for arc secant, arc cosecant, arc cotangent, is we can simply take this function and switch it to the arc cosine function of 2 over x. Like that. Okay? So that's the first thing you would want to do then. Right? Now, yeah, that's not a decimal point. What's that? It was x over 2 originally. I think that's what it was originally. And so it would be 2 over x. Right? Now, so now we need to do that derivative following the arc cosine rule, which is -1 over the square root of 1 minus u squared, right, times the u prime, right, derivative inside. So, -1 over the square root of 1 minus 2 over x squared times, now how do we do the derivative of 2 over x? Okay, the best thing to do would be to write 2 over x as 2x to the -1. But in the other class, a couple people said quotient rule. Now that'll work. My advice has been avoid the quotient rule if you can. But that's up to you. I mean, here's when you have to do the quotient rule. When you have some x's divided by some x's, and you can't simplify and cancel or whatever, then you've got to do the quotient rule. But if you have a constant over some x's, you can always flip the x's up, even if you have this. Even if you have a big mess of a thing down here or whatever, you can flip that up and make it x plus 3 to the -2, and then do a chain rule kind of thing. I would prefer to do that, but if you'd rather do a quotient rule, go ahead, you can do it. But what I've noticed is people a lot of times mess that up. And likewise, if I had some x's on top and only a 2 on the bottom, I would not do the quotient rule there. What can you do with that 2? Bring it out in front as a 1/2, and then you can just do a chain rule. So anytime I've got just a constant alone on top or on the bottom, I'm not going to do quotient rule. Okay? I'm going to flip that up. Now, we did it in the other class because several people had tried it, and it works. I mean, it comes out the same. It'll work. But what usually happens is people mess it up. Like, you're supposed to do the derivative of the top. Well, what's the derivative of 2? 0 times the bottom left alone minus the top left alone times the derivative of the bottom, which is 1. Did I do something wrong there? No, okay. Over the bottom square, right? So what do you end up with? You end up with 0 minus 2, so you end up with -2 over x squared is what you end up with, right? Now, if you would have written that 2x to the -1, do the derivative, you bring down the -1, you get -2, drop it to, oh yeah, those are the same, right? -2 over x squared. So it can work. I mean, so go ahead and do it, that's fine. So anyway, we get negative 2x to the negative 2 right here. Now what you would need to do is multiply these two negatives together, right? And get a positive. I just put the 2x to the negative 2 up on top and just leave it. And this would be 1 minus this. Now on the bottom, do you need to square that? I'd say no. I mean, it's probably pretty easy to square. It'd be 4 over x squared, whatever. But on the gateway, if you left that inside the arc sine or arc cosine when you have to square them, if you leave it like that, that's probably okay. If you think you're going to mess it up when you square it, just leave it. That's good. Because usually, I can't hardly think of any time where I'm going to want you to do something with that. Now, if you look this up in the back, they a lot of times don't like to have a fraction inside that square root, so they'll pull some things out and do some different algebra to it. But that's beyond the algebra I'm going to make you do. Okay? So if you stopped right there, that'd be good. But you would need to multiply those negatives and get that to a positive at least. Okay? You guys? I think, you know, it's funny. I thought, oh, she's going to be late to basketball practice. Okay. We already had practice. All right? Okay. So anyway. That would be late to the game. We'll miss the first quarter. We got to host. All right. So anyway. Okay. Any others? Any others on the homework? Again, the ones with the arc sine and the arc cosine, you know, the unit circle kind of stuff, that isn't nearly as big a deal. For right now, it's not a big deal at all as far as the gateway test goes. That's not even beyond it. Just the derivative rule, right? Just doing the derivatives. That's what we got to be able to do. Okay? All right. Well, let's talk about 195. Anything on page 195? Any problem that you tried and couldn't get it figured out? I knew somebody was going to ask. Anybody try number 40?
Yeah.
Nope.
Yeah.
I got to 39 and then I went all the way back up to 29.
That's not what you do.
No. Well, you didn't do the derivative inside.
I did 30 through 39.
That part is right.
No.
Oh, but I didn't finish it.
Well, yeah. And the finish is the biggest part. So what it is, it's ln. So everybody looking at it, it's a mess, right? I mean, that's why I think. I mean, if you look at that page at all, it kind of stands out. It's ln of the square root of a big quotient, right? So it would be ln of, and I'm going to make that square root the 1/2 power right away. Okay. And then here's a couple things I would do. So on number 40, so we got that big square root. So that's going to be 1/2 power. Then I also notice the top says x times x plus 2, right? I would distribute that through. Because if I leave it like that, then I have to do a product rule. And, you know, there's enough going on here without having to do that. So I think I would distribute the x through there. And so the top would be x squared plus 2x. And the bottom, what's the bottom? X plus 3. So it ends up being that. Now remember, what's the rule for natural log? Well, okay, the new rule on the new page of rules I gave you. That's not 1 over x. 1 over u times u prime. I've talked to several people today that have done plus on this. It's never plus with the u prime. It's never plus with the derivative inside. It's always times the derivative inside. Okay, times the derivative of the inside. So it's 1 over u. Now what's the u? All the red stuff right here. That whole big square root. That's the u. So the derivative of this is going to be 1 over, now I'll go ahead and use the square root with, no, let's leave it 1/2. Let's leave it 1/2 for now. Okay, so 1 over the whole big thing, x squared plus 2x, right, to the 1/2, so it's 1 over that, times the derivative of the inside. So we've talked about putting a big set of parentheses, right? Because sometimes that's most of your work. Well, in this problem, by far, that's most of the work. You do 1 over the stuff on the inside, Now you got to do the derivative inside. So now all I'm worried about is doing the stuff in the red. And I know it's going to go in these parentheses. Okay, so what do? Well, it's a power rule, right? What's the rule for a power rule? It's u to a power. The derivative is n times the stuff with the power dropped times the u prime, the stuff inside. So we're going to bring down the 1/2. We're going to leave the fraction alone to the negative 1/2 times, and I'm going to change colors, the derivative of the inside. So again, big set of parentheses, but if you just, this problem's really like that old saying, how do you eat an elephant? One bite at a time. One bite at a time. That's exactly, this problem is like the elephant of all the problems on page 195. That's the old saying. So you just start where you're supposed to, but it really helps you to organize it, I think, with the parentheses. So now I'm only looking at the blue thing, right? Now I've got it down to all I care about is the thing in blue, because I'm now doing the derivative of the inside. So I was doing the red, so I did the power, brought it down. Now I'm doing the blue. So the derivative of that is a quotient rule. So derivative of the top, that's going to need parentheses. 2x plus 2 times the bottom left alone minus, okay, the top left alone. You'll need parentheses. X squared plus 2x times, oh, that's nice, 1, all over, because I was running out of room, the bottom square. Okay? Now, just the part in the blue I'm nervous about. I mean, on the gateway, that could be a problem, right? Just the blue. That'd be a quotient rule. That'd be a pretty easy one. I mean, really, it'd be a pretty straightforward just quotient rule, just that blue part. There are a lot of places you can get in trouble on just the blue, right? Forgetting the parentheses, not putting them in there like you need to, and so forth. Because there's some simplifying that can be done with the blue. Okay? We need to FOIL that out and see what happens there. But I can see people not putting parentheses. Now keep in mind, anytime you do a quotient rule, it's basically 4 things on top with a minus sign in between 2 of them. I mean, that's basically the quotient rule, right? And you should have parentheses there most of the time. Now sometimes it turns out you don't need them. And we were talking earlier about factoring, right? And so when you're looking at factoring, you're looking to see if you have factors here and a factor here that you can factor out. Okay? But because think about quotient rule. It's the derivative of the top times the bottom left alone minus top left alone, derivative of the bottom. So you always want to think about that as you're organizing your work. Okay, so let's do the blue here. So we FOIL that. We're going to have 2x squared, 6x, 2x would be 8x plus 6. This would be minus x squared and minus 2x. So the blue here would be 2x squared plus 6x. Oh wait, did I?
Just be x squared.
It'd just be x squared. Yeah, I was going to say, I thought it was something different. Just x squared. X squared plus 6x plus 6. All over x plus 3 quantity squared. Now, I'm not going to FOIL out that. I FOILed out the top. Usually you don't want to FOIL out the bottom because you're hoping some things might combine on top, maybe even factor out something that would then cancel. So you want to leave the bottom in its factored form because you're thinking you might be able to cancel some stuff here. Okay, now let's see what we got. So that blue thing is one kind of factor. As I look at my whole problem, because this is what you want to see with combining things. This is one whole thing here, times, and then I got the big parentheses, but since there aren't any plus signs really in between the components here, I really just have a bunch of things that are multiplied. I got that, and I got that, and I got that blue thing there. They're all multiplied, so really I could just rearrange these any way I want now at this point. Okay, so this 1/2, for example, I'm going to bring that way out here. And now I'm looking at these two things. Right? Look at these two things in red, this thing here and this thing here. Well, can I do something with these two? I mean, this is on the bottom, so what can I do with that? make it negative 1/2. And then I would have this to the negative 1/2 and this also to the negative 1/2. And they're the same. What can you do there? Well, not cancel, but add the powers, right? I got something to the, it's like x squared times x squared. It's x to the 4th. You add the powers. So I got this and this, both to the negative 1/2. Add the powers, and that'd be negative 1. Okay? Oh, and that's going to be good too. This is getting better all the time. So if I have this, I'm going to go to the next page here in a second. But when I put these two together here, that's going to be to the negative first. Well, how can I turn that to the positive first? Flip it. That's going to put an x plus 3 on top, and look what I got over here. X plus 3 on the bottom. Right? So, well, maybe I won't go to the next page. Maybe I can do it right here. So what I've got is a 1/2. I've got an x plus 3 over an x squared plus 2x to the first when I flip it. And then the other thing over there is x squared plus 6x plus 6 over x plus 3 quantity squared. This x plus 3 would cancel one of those x plus 3's. And I would have, finally, x squared plus 6x plus 6. Somebody type this one into the calculator, by the way, the original one. Let's see what the calculator gives us for a derivative. I'm just curious here. Nah, because then that would add to 5x. That would add to 5x on the outers and inners. Yeah, I thought of that earlier. I was thinking if that would factor in it, but it doesn't. So now on the bottom I got a 2. Now I can pull an x out of here because I think the calculator is going to. I can pull an x out of this one right here, right? So I think the calculator is going to have a 2x, then it's going to have an x plus 2, and then it's going to have an x plus 3, I'll bet. Because I've done enough like this to know kind of what the calculator is thinking. Let's see if that isn't what the calculator is. Is that what it is? X squared plus 6x plus 6 over 2x, x plus 2, x plus 3. Yep, that's what we got there in the bottom corner. Okay? What's on the calculator? On the square root. Now remember, when you do a square root, yeah, I've noticed a lot of people doing that. When they do a square root to a power, they always put it to the negative 1/2. Square root's not negative 1/2. Square root's just 1/2. It's on the bottom, it's negative. Okay? Would I give you one like that?
No. You give the other.
Well, that would be a heart. That would definitely be a heart. Yeah, probably not that much stuff, but the blue simplifying for sure, where you could do some of this and some things could cancel, but yeah, probably not quite that extensive. All right, what else? What's 36? Oh, that'd be a good one to do with the log. So the log base 10 one?
Yep.
So we got log base 10 of x all cubed.
Yes.
And then what's on the bottom? Tangent x. My guess is a lot of times not as far as canceling because there's a mixture of these different things. Yeah, I mean, so this is first, what rule are we looking at first? What?
Oh, I did the.
It's really a quotient rule.
But yeah, but then you have to do the power.
But there's power rule in it. There's all those things in it. But really, this is a quotient rule. It's got some stuff divided by some stuff. So this is a quotient rule. Now, remember what I said about the quotient rule? 4 pieces, right? The first of those 4 pieces is derivative of the top. Now, when you do the derivative of the top, that's going to be kind of complex, right? Because you got a power rule and you got an inside and all that stuff. So the first part of those 4 is going to be kind of tough. As a matter of fact, it wouldn't hurt to do that, to look at that and say, you know, here's going to be my quotient rule right here. It's going to be something like this, and I probably gave myself too much room there. But anyway, it's going to be something like that, okay? And that's the quotient rule, and then the bottom is going to be tangent squared, right? So it's going to be, I'm not saying I would start it this way and actually put the parentheses out there, but you got to be thinking of it that way. You got to be able to see the big picture. You get lost in the details early, and you lose parentheses, and you put things in the wrong places. So now I need to do the derivative of the top. That's what's going here. So it's a power rule. So I'm going to bring the 3 down in front. I'm going to leave the log base 10 alone. To the second, thank you, times the derivative of the inside. What's the derivative of a log base 10? I'm going to use the u, but it's 1 over u times 1 over ln the base, right, whatever that is, and then times the u prime. Now it turns out you're right. X is in the inside, so our u is just x, and the derivative of x is 1, so we don't have to worry about that. But it is 1 over the inside, which is x, times 1 over ln 10, and then the derivative of the inside is just 1. Okay, so there it is. So that's the derivative of the top. I mean, that right there could be a problem in the gateway test, right? Just being able to do the derivative of log base 10 of x all cubed, right? So that's just part then of our quotient rule. So derivative of the top, we leave the bottom alone. Minus the top left alone. Times the derivative of the bottom. What's the derivative of tangent? Secant squared. And now, you start looking at that, and of course, what I would look at first, about the number one thing we're looking at to simplify is, or there's some things that just multiply together, like a 2 times a 3, or an x squared times an x cubed, that would be x to the 5th. And I don't see any of that in here. I mean, the 3 can't really multiply with anything here. I mean, I can put these together and rearrange them, but that doesn't really do anything. Here, there's nothing really here I can put together. And then the other thing you're looking for is the factor and cancel. So I always look down at the bottom, right? Instead of looking at the top and seeing what can factor out, I just look at the bottom and see what I have to cancel. What I got to cancel. Tangents. So the only thing I'd want to do is be able to factor out the tangent. See, some people think, hey, I'll just cancel that tangent. Well, that's why I went over that thing at the very beginning today. You can't factor out the tangent. It's not a factor of the top. It's not over here. You'd have to factor out a tangent and then cancel. But we can't. There's no tangent in there. So you're done. So that's a great example. That's a good one to do right after that other one. Because that other one had some stuff and it got pretty messy, but it did work. This one, you just do that and you're done. Now that's quite a bit. I mean, if you can get all that right, exactly right with the 1 over ln 10 and remember all that, that's good. Because you have to remember those things. Those are the rules we have to know. Okay? Any others? All right, well, here's what I'd like to do then. I want to show you the 2 websites here. So this is the class. Now, somebody in the other class brought up not being able to watch the videos on their Chromebook. Now, the person who brought this up hasn't been gone, hasn't had the need to watch them, and all of a sudden they needed to the other day and they couldn't watch it. And there was a problem with YouTube. There's like a safety mode or something. Is everybody aware of that? Okay, if you go on YouTube, down at the bottom, I think, well, here, just think I'm on YouTube right now. Right down here, when you're on YouTube, it says safety on. Okay, when you hit that, you have choice, on or off. You want off. Okay, you want safety off, and that works on the Chromebooks, and then you can do it. And now, does that open up YouTube like for anything on your Chromebooks, or are you filtered ones? Well, I don't know, but I know you can watch the videos if you do. Okay, so all right. So back to the class website. So on the website here, down here where it says web links, and I also put it here in today's homework. Okay, on Friday, December 5th, I got links to practice 1 and practice 2. Or if you go on web links here, it's the first 2 things. Okay, so if we go to derivative practice 1, so go ahead and get your papers out here, and let's do a little practice here. We'll find some. Now the only downside to this website has some nice advantages. And there's 3 places you should be practicing now for your gateway. Page 195, okay, which is good. I would try to do all those problems sometime before Tuesday, probably, on page 195. I mean, that's a lot of good practice. I'm not going to assign you a number from here on out. On Monday, when I come around and look at homework, that's just going to be, show me the problems you practice, okay? And I think you should have a fair amount, but some people might need more than others. Problem is, the ones that need more than others sometimes are the ones that do the fewest. But so what page 195 is one place. Another place is this website, and then the third place would be the other website. And we'll talk about the advantages and disadvantages of each. The advantage to this website is you can pick the different types of functions you want to focus on, like tangent. I mean, all of these first 2 rows. Now, this bottom row we wouldn't do, but inverse sine, cosine, tangent, secant, cosecant, these we need to be able to do these. And then notice it says polynomials, rationals, power functions, root functions, plus these. So just because you check these boxes doesn't mean you're going to get these. Okay, so I've chosen just kind of the easy ones, e and ln and sine and cosine. Okay, that's too easy. We won't do that one. Let's don't do that one. It's too easy. Too easy. What am I on? 3 here? That's too hard. See, this is one of the disadvantages, right? I mean, you're going through here and you're like, "Whoa, this we good to do." I mean, this is a pretty generic one. I'm kind of surprised. That seems pretty easy for 3. Let's go to 4. Well, there was one that was too hard too. Yeah, I wouldn't do like a decimal power. They're getting kind of ridiculous. All right, here we go. Let's do this one. So we'll do one of this, but sine x, okay, just work this one real quick. Sine x plus ln of cosine x. Sine x, yeah, plus ln of cosine x. That's the problem right there. And I'm going to put the answer up. Don't look if you don't want to yet. Do I want you to do the last step? Or do you want to go farther than what I did? Yeah, because sine over cosine is tangent, right? And I don't care. Actually, on this one, you could stop at any of these here or here, because really all I did there is rearrange. I just moved that on top, okay? So I don't even care if you do this last step, but yes, cosine minus tangent would be a correct answer, okay? So, and that one was not very hard. I mean, that shouldn't be, by Tuesday anyway, for the gateway test, if you've practiced, that should not be hard, okay? And that's got your basic sine, cosine, natural log. That's one of the reasons it isn't that hard. Now, if we go to here, and let's go ahead and uncheck these, and let's do, say, these right here. Maybe throw a tangent in there. Okay, let's see what we get. All right, let's do that one. 10 times 3 to the x. And to be honest, if you know your rules, this one isn't really hard either because it doesn't have any chain rule or product rule or stuff like that. But 10 times 3 to the x minus 8x minus log base 6 of x. All right, I'm gonna put it up here. Okay, is that any questions there? Now the 10, this is not a product rule here, right? Because, oops. Right, the 10 is just a number multiplied in front. It just hangs out there. Like if you had 10 sine x, the 10 just hangs out there. So it's 10, the derivative of 3 to the x is 3 to the x times ln 3. There's no derivative of the inside because that'd be 1. 8x, derivative is 8, and then log is just 1 over x times 1 over ln 6. Okay, so that gives you some practice on those kind of other bases of logs and exponentials. So that's one of the advantages of this website is you can pick and choose. Okay, let's do one more on this website. Let's do an inverse trig and maybe secant, cosecant, one like that. Let's see what we get here. Now notice you get some that aren't that. You get some that have some powers as well. Ooh, man, that was a little nasty. Kind of looking for one that's got a combination of those two. Oh, see now that's just silly. I don't even know why you would do that. Okay. Okay, let's take that square root x off there and do this one. So y equals 4 arc cosine. Let's make that x squared minus cosecant of 2x. Let's do that. So I'm guessing the paper shuffling I heard was looking up cosecant. Is that what we were doing? Okay. Okay, well, I was gonna try to. There we go. Let's see if there. So, that's what I got for the first. Now, I went ahead and put the 4 on top with the arc cosine, right? I could have just put the 4 in front and then done the -1 over, but it's just, when you do a few of those, you start realizing, okay, if you got a number in front, you can just put it up on top where the 1 is. Okay, so, right, but that's our cosine, right? Our cosine's -1, and with the 4 makes -4. And then the square root on the bottom, 1 minus u squared, here's the u right in here, right? So 1 minus u squared, so it'd be x squared, times the u prime, the derivative of the inside, so derivative of x squared is 2x, minus, and then you looked up cosecant, you saw it's negative cosecant u times cotangent u, so negative cosecant 2x times cotangent 2x times the derivative of its inside, which is 2. Now, what can we do with that? So this negative, since this is all multiplication here, this can turn to a plus, and that can go on top with that. And so we'd have something like that. Now, I don't care about the x to the 4th here. If you want to leave that x squared, that's okay, because like I said, we don't ever really do anything with that, I don't think, to speak of. So that's kind of your final answer. And usually we put the 2 around in front, but it wouldn't have to. It's just rearranging. Yes?
Does it matter if we move the -8x on top, or should we have it times the 1 over?
Yeah, you could have the -8x here and the 1 over. That's fine. Yeah, that's fine. Again, that's just rearranging too. So having it on top or having it out in front with the 1 over is fine. Okay? It's kind of like if you did a 2 times ln, I mean, just do real simple ones here. If you had to do the derivative of 2 ln x, you could do 2 times 1 over x. You could just leave it, right? It's the same as 2 over x, but you can just leave it 2 times 1 over x. You want to know that you can do that, obviously. As we get into other problems, you're going to want to probably do that. It makes the rest of the problem simpler. But for now, on the gateway test, you can stop there. Okay, so that's that website with some different options of things you can do. Now, but the downside to that is, is this one we need to do? I mean, you might be a little more unclear when you look at one. Would this be a good practice or not as good? Whatever. I mean, and the more of these you've done, the more you probably have a feeling for the kinds we've been doing and so forth. But any along this row, those different rules you need. So that's the advantage of that website. Okay, now, the other website, and let's talk about page 195. Page 195 has a lot of good problems. What it doesn't have is implicit differentiation, when you have the mixes of x's and y's, okay? And that website doesn't have any of those. So implicit differentiation, you're probably going to need to go back to the section on implicit differentiation, or make up some of your own. If I was going to do it, I would just say, okay, I could have x cubed. Think about the ones we did. 2x squared y. I always like to get an x and y together, where you have to do a product rule. Plus maybe y to the 3rd equals 17 or something. Those were the kinds we did a lot of. And so those, you can just make those up. Now, it's hard to check them because the calculator doesn't really work. And you have to show it to each other and help each other out, or maybe show it to me and I can do it. So that'd be one option. But the third of your practice places, which is this website, you've got some practice tests here. And they're just PDFs. So you can print them and work them out there, or you can just read off of here and just do them on your own paper, whatever. But they start out pretty simple. Derivative practice 1, pretty simple, just regular x's and stuff. Then you get into some quotient rules. You get into some e to the x's here. And you get into some that you can simplify algebraically first. You get into some negative powers. That's about it on the first one. Okay? Then the second one, you get into some chain rule. So you start getting into stuff on the inside. And you get into some product rule. And like here's a 2 to the 3x. So that's your ln2. That's where you got that special rule for that one. You get into some quotient product rules. So this has a lot of good ones. Practice number 2 on this website has a lot of really good ones, the kinds that we would be having on here. You get into some arcsine and arctangents and arccosines here into this as well, along with some product and quotient rules. So this has a lot of good ones. Then they start getting a little more complicated. You got stuff on the inside, and then that's inside of something. So we did a few of those. Another quotient rule one there. This has a lot of problems. Okay, there's a bunch of them here. So there's 42. So there's a bunch of problems there. Okay, practice 3 gets into, this is where you're going to see some of the arcsines again. This is just some more pretty decent problems, really. Now you start getting into some implicits. So in worksheet number 3, practice test number 3 here, right here, number 9, has got a mix of x and y's. Here you get down to 13. There's another one. 16 is one. Now 17, we haven't done a quotient rule one with that, so I probably wouldn't give you one of those. But actually, it wouldn't be. It's not very much harder. It's pretty much the same. But here's another one. Here's a good one. 18, 19 kind of has some square roots. We didn't really do much with that, but that's one. 20 looks a lot like a couple we did in our homework. Number 21 and 22 in our homework. So you got one there. So that page has a few of the implicit differentiation ones as well. Okay, and then it's got them worked out. I believe it's got the solutions here. I haven't looked at those, to be honest. Looks like they just have them written out. They got the problem and the answer written there. So you can take a look at those. And then I'm not sure what this is. This must be the actual test they gave. This must have been the actual derivative exam. How many problems did they have? 15, it looks like. So it looks like they had 15 problems. So this is the actual test at this college. This was at Arizona State for this professor back in 2003. And it gives the function and then it gives the answer. So you got some more practice there. Let's see, how hard would this test be compared to ours? There's a product rule. That's a pretty easy one. There's a quotient rule. Actually, you could simplify that one first. You could split that apart. You could do a little simplifying. There's a chain rule. That'd be very doable. There's a quotient rule. That's not bad. You can distribute that. Here's an arctangent, so we've had those. Cotangent, we just talked about an arcsine with something inside. Here's a chain rule. 56 power, that's interesting. E to the cosine. A couple of implicit differentiation ones. Yeah, that looks similar. Maybe too easy, but okay. All right. A little easier than ours, but we are currently on Arizona State. All right. So the rest of the time, last half hour, is your time. You can work. You can get together and work. You want to get on the website, on your Chromebooks, whatever.